So for the first problem, you have multiple terms with variables in it, so you isolate them on one side of the equation, which is already done for you. Next, you look to remove any common factors. What common factors can we remove from these two terms? For x, leaving x plus 3. Set each of those factors equal to 0. So our monomial factor gives us x is 0. Our binomial factor, what value of x would give us a 0 here? -3. So those are your solutions. Again, when you write your answer online, I'll write it from least to greatest. So you would write -3, 0 for your answer. All right, the second example, again, has multiple terms with a variable in it. So look to move everything to one side of the equation. It's already done. And so now we look to see, can we factor this? Because eventually there might be some problems that can't be written as factors. Easiest thing to test to see if something has rational zeros is if you take your leading coefficient times your constant. 3 times +2 is +6. Are there two factors of that product whose sum is the middle term's coefficient? Yeah, +3 and +2, right? So you know that you have binomial factors here. Now, the fact that our leading coefficient and constant are prime numbers tells me I'm going to reverse FOIL because it'll probably be easier to do that than to rewrite the middle term. So my binomial factors have to yield a product of the first terms of 3x squared. So the only combinations for that is 3x and x. My last terms have to yield a product of +2. So that's either, you know that the signs are going to be the same because it's a positive. The outer and inner products have to add up to +5x. So you know that that sign has to be a plus. And so the only two factors of 2 are +1 and +2. So there's either a 1 here and a 2 here, or a 2 here and a 1 here. So we only need to test 2 different combinations for trial and error. If I put a 2 right here, when I take my outer products, it's already 6x. It would be more than my middle has to be. So I'm going to put my 2 here and my 1 here and test it. My outers are +3x, my inners are +2x. Does that give me my outer and inners 5x? Yeah. So those are your factors. Set each factor equal to 0 and solve. So here in this first factor, I have a leading coefficient other than 1, so I'm going to take the opposite of my constant and divide by that leading coefficient. So the opposite of 2 is -2, my constant, or my leading coefficient of 3, so I get -2/3. And my second factor here, since the leading coefficient is a 1, you just take the opposite of your constant. Opposite of my constant, -1. So those are my two solutions. When you write your answer, you would write -1, -2/3. You go from least to greatest. Remember, least means furthest to the left on a number line. All right, that brings us to this last problem. The last problem, you look to see you have two binomial squares, and we don't have any patterns that allow us to factor it in this form. So what we can do here is expand everything out, combine all our like terms, and then look to follow our process of factoring. So if I take the binomial square x plus 5 squared and expand it out, I square my first term, take the product of my terms and double it. X times 5 is 5x, doubled is plus 10x. I square my last term, 5 squared, which is 25. I'm going to do the same thing with my second binomial square. Square the first term. I square the 2, square the x. Take the product of these terms and double it for my middle term. 2x times a -7 is -14x. Double that, I get -28x. And then finally, my last term squared, -7 squared is plus 49. And that's all set equal to 82. Okay, so now I have multiple terms with variables in it, so I'm going to move everything to one side. I'll subtract 82 from both sides here and combine my like terms. X squareds, I get a total of 5x squared. 10x minus 18x leaves me with -18x. And 25 plus 49 then minus 82, it's going to leave me with a -8. And that's all set equal to 0. Once I get to this step, I do want to test and see, can I solve this with rational zeros by factoring? Easiest way to look at that or test it is take our leading coefficient times our constant. 5 times -8 is -40. Are there two factors of -40 whose sum is this middle term's coefficient? -20 and +2. Okay, that means that we can find binomial factors for this. So because my my constant is not a prime number, I'm going to go ahead and rewrite the middle term on this one. So if I group the first pair and second pair, in this first pair of terms, what common factors can I remove? 5x, leaving x minus 4. In my second pair of terms, what common factor can I remove? Just the 2, leaving x minus 4. So I have this common binomial factor, x minus 4, that comes out. My remaining factors of 5x and plus 2 form the other binomial factor. That's all set equal to 0 here. And so now I just use zero product rule, set each of these factors equal to 0. My first one, I get x is 4. My second one, again, it has a different, it's a leading coefficient other than 1, so I take the opposite of my constant, negative 2, divide by my leading coefficient, 5, and that gives me my solutions. Again, if you were writing this, you would write your least to greatest, negative 2/5, comma, 4 would be the solution here.